initial fears of C#. Sections 2 and 3, we set up our first-person movement with a rotating camera and build the foundations. We'll then add shooting mechanics, bullets, and targets to destroy. Sections 4 and 5 are advanced movement and shooting, where we take things to the next level with jumping, sprinting, and sliding while controlling our shooting rate, adding ammunition, and displaying it all. Rotate this object that has a script on it will put, and we're going to here next to projects. Great. Now, first thing, what are we going to do? We are going to create a game object, and it's I will use the magic of edit. Windows are in, have click and enter, we can save. I've talked about namespaces, about the start and the update. I will not be going over them again because later on we will also delve even deeper into them when we start our first Magic GameCube 3D. So let's start by first of all printing something to the console, and the way we print things to the console is we simply write in here print, and immediately you can see that even without finishing the word print, Visual Studio, our dear friend, helps us out and tells us that you are kind of writing print, so let me help you out. When you get to this point and you don't want to finish writing your own sentence, simply hit the tab button and Visual Studio continues automatically. So we need to open up these brackets, and you can read under the code right here that this logs messages to Unity's console. Perfect. So this is what we actually need, and you can see also the way that we need to add a message right here, and this message can be or should be a string. And what a string is it's a type of variable that we'll talk about later on, but all you need to understand that a string is something that we put between these two quotes right here, and it's a string of characters, so we can write words and sentences inside it. So first thing we're going to write, of course, is hello world with an exclamation mark. And you can see that here we have this squiggly red line, and what this means, it's an indication from Visual Studio telling us that whoa, there is a problem here. And the problem here, if we hover over it, is that it is expecting this semicolon right here. So we add it, and every line in C# needs to have a semicolon at the end of it. Now we need to save our script before we go back to Unity, and whenever you haven't saved your script yet, you can see this little asterisk right here on the hello world.cs, and to save your script, simply click on Ctrl S and it will be saved. When it's saved, there is no longer the small asterisks. Great. Now let's go back into Unity and wait for the Unity to understand that we've done some changes. You can see that it's changed right here in the inspector. And now, when we click on play, we should see something in the console, but that will not be the case. Let me demonstrate. So, when we click on play, we look in our console, but there is nothing there. Why is that? Well, because we haven't attached our script to anything. So even though we've created our code and it's very well written and should work perfectly fine, it's not attached to anything in our game scene or in our game. So let's change that by creating a game object. We can also attach it to the main camera or the direct light, but we'll not do that. We'll create our own game object, and the way we do that is by right-clicking in the hierarchy, and let's go down, and for now let's simply create an empty game object. So this is an empty game object, and here you can see the transform, which is the position, the rotation, and the scale of our object. So if we click on our game object, hit the W key, now we can change the position of this game object up and down and left and right in all sorts of direction, and we can reset its position by going up here and hitting these three little points right here and hitting the reset. So the transform's position, rotation, and scale will be reset to zeros and ones. Great. Now what we want to do is we want to attach this hello world script to our game object. The way we do that is very simple. We can either drag the hello world into the hierarchy on our game object, or we can drag it right here in the inspector if we have game object on it. So let's do this right here. And as you can see, a new component has been added to our game object. So now our game object, which is part of our scene, which works inside of our game, has this script attached to it. And this script that is attached to something in our world is telling it, or telling the game object, that you need to print out hello world to the console. So let's see if that works. Let's save our scene. Also, you can see we have an asterisk, Control S, click on play, and now if you go to the console, you can see that it says hello world. Nice. So we can now rest assured that this actually works, and now that you have complete faith in the workings of the scripts and Unity, it's time for your challenge. And your challenge is to print your own name. So instead of hello world, print your own name on the console. And to Unity, and whenever you inspector, and now when we click on play, we should see something in the console, but remove the clear on play, and now when we click on play, we have hello Michael, and we can clear all of that. We can then go back and click on play again, and we can see hello Michael. So this is your introduction to Unity. This is a very important part. This is where we get over the fear of using code. This is where we get over the fear of using Visual Studio. As you can see, can you? So I'll see you in the next video. Welcome back, my fellow game developers, and as you can see, we've already created a 3D scene with an object called shape spawner, and we've added a script to it, which is a shape spawner. We've explained what all the what namespaces are, what start is, what update is, and we've actually printed a couple of lines right here in our console, but not just a message, we also printed a warning, and we've printed also an error. So let's not waste any more time and let's get started. Okay, so first thing we're going to do is we're going to create a new project. So open up your Unity hub right here, click on new, and here we can choose which kind of project we want to create. So it's going to be a 3D project, and it's going to be called the Magic Game Cube 3D. Very nice. So let's go ahead and create, and make sure that you have the proper location for it to save in. Mine is in the D directory inside of Unity project. So click on create, and we are simply going to wait for it this whole time. But because I have the ability to use magic of editing, I'm going to simply skip through this whole process, and I'll see you in just a bit. Okay, great. So now you should have the same view as I do whenever your project finishes compiling. If you don't have the same view, you can go right here into the default, and into the layout, and click on the default one, and this should give you the same layout that I have. Okay, great. Now that we have set up the interface, it's time to first of all create an object. So we go into our hierarchy right here under the sample scene, and actually let's go ahead and change this sample scene, and let's simply make it our level 1. We won't have any other levels, but just to get into the habit of naming our scenes, we'll name this level 1. So right click in our hierarchy and go ahead and create an empty game object. And as you can see, it's spawned in the middle of our scene right here. If it's not in the middle, you can see right here that it's all zeros. You can actually reset its position. So even if it's some kind of different position than mine, you can simply reset it, and it's going to be on the 0, 0. Very nice. Now, this game object is going to be our shape spawner. It's where our shapes are going to be created. So we'll name this our shape spawner. Cool. So now we have a shape spawner in our scene. Next thing we need to do is we need to create a script for our shape spawner. So let's go ahead and do that. Right click in inside of the project, go to create and C# script. And this script is going to be called shape spawner. Let's click on that and wait for it to compile. Here we have it ready to use. And before we forget, let's go ahead and add it to the shape spawner in our hierarchy. And now if we click on our object, you can see that the script is attached right here under the transform. Very nice. Next thing we're going to do is we're going to simply open this up, and it should open up in Visual Studio. And wait for it to open up. Okay, great. So as you can see right here, we have a lot of code that is already present, and let me just take you through it a little bit before we get started. So here we have these 3 lines which are using system collection, using system collections generic, and the using Unity engine. And what these update, which we'll get to in just a bit, and it will allow us to manipulate the behavior of certain objects which are present in our Unity update, which will entities. So for example, let's explain the Unity engine right here. This allows us to first of all use the start and update, which we'll get to in just a bit, and it will allow us to manipulate the behavior of certain objects which are present in our Unity engine right here. So for example, we can access the shape spawner, we can change its position, we can do lots of things because we are using the Unity engine namespace. Now, under Unity Engine, you can see that it's a public. We'll go over what is public. It's a class, and it has a name of shape spawner. Now, this shape spawner is the name of the script that we gave it, and that's why I always tell you that you need to make sure that whenever you name your script, that it's the name that you are going to stick to. Because if you change the name of the script, the name of the class won't change, and there will be lots of errors in the future. And mono behavior is, as you can see right here, it's every Unity script base that you can use. So mono behavior allows you to use the start, the update, and other functions that we'll be using later on. So let's talk about the start. What is the start? Well, the start is called on the frame when a script is enabled just before the update. So what does that all mean? If we go into Unity, for example, and we click on play, when we start, so now we've started, the start method in the shape spawner will start. So it's the first thing that starts whenever we go into our game mode. Let's go out from here and back in Unity. So next thing we have is the update, and the update is called to use the L, O, and then I press on tab and it continues whatever option I've chosen. And inside of here, we're going to write a message which is going to be, hey there, I'm using debug in start. So let's close that, and always remember to add a semicolon. And now if we go into our Unity, we click on play, we should see in the console right here that, hey there, I'm using debug in start. Very nice. And if you don't have the console, go into the window, go into the general, and you should have the console right here ready for you to use. I've docked it next to project because this is my favorite place to dock the console. Now let's go ahead and see what happens if we use this line right here inside of the update. So let's copy that, paste it in here, use the debug to print something. And you can see that we have every single frame we are printing to the console, hey there, I'm using debug in update. Very nice. So these are the basic way of printing things to our console, and we will be using it later on for, well, debugging. This is used, for example, if we have a method and we're not sure if we're actually entering that method or function, we use the debug to print something, and that will enable us to understand if we have anything working. Now, another thing, or another feature of debug, we can play in Unity, hey debug dot log warning. So instead of simply printing a message, we can actually print a warning. So, hey there, this is a warning with an exclamation mark. Let's close that and let's see what happens when we click on play in Unity. So we click on play, and as you can see, hey there, this is a warning, and it's actually a different kind of symbol right here. If you can't see it, you should look right here on your right, and you can actually disable and enable if you can view errors or message or warnings. So the warnings are like, this is a warning with an exclamation mark. Let's close that and let's see what happens when we click on play in Unity. So we click on play, and as you can see, hey there, this is a warning, and it's actually a different kind of symbol right here. If you can't see it, you should look right here on your right, and you can actually disable and enable if you can view errors or message or warnings. So the warnings are like, they are a step above the normal messages. That an error means that we have something very fatal. So hey there, Welcome back. Click on play, and inside of console we can see that press the left arrow key to go left, arrow key to go fatal. With two exclamation marks. Oops, with two exclamation marks. So let's save that. Let's go back into Unity. Let's click on play. And inside of console, we can see that press the left arrow key to go left. Don't press the right arrow key to go left. And pressing the right arrow key to go left is fatal. So I hope you enjoyed this very simple video. It's nothing new. We already Welcome back everyone to a brand new video, and in this one we are going to learn all about variables. So as you can see right here, there is nothing that really catches the eye. It's simply numbers and words, but if we look deep down into our code, we can see that we've added three variables. One is float, one is integer, and one is string, and we've actually integrated our variables inside of our debug.log, which is a very cool aspect of coding and extremely helpful and versatile, and it really takes us to the next level of coding and writing C#. So I hope you enjoyed the video, and let's not waste any more time and get started. Okay, so what are variables? Let me tell you all about variables. So let me put on my laser, and now we're ready to go. So variables are like boxes. So let's say we have a box, and this box has a name, and the name of this box is lives. So what do we do with the box? Well, we put things inside of it. So we put in, for example, a 3 inside of the box. So now we have a box that has a name of lives, and it has an integer which is 3 inside of it. And this is exactly how variable works. So this is how we introduce variables inside of our code. We have the public, which is the accessibility. We have public and private variables. Public variables can be used anywhere in our code. Private variables are only used inside of the script or the class, which are the same, that we've created. Then we have the integer, and this is the type of variable that we have the public, which is the accessibility. And this is exactly how variable works. So this is how we introduce variables inside of our code. We have the public, and the name of this box is lives. So what do we do with the box? Well, we put things inside of it. So we put in, for example, a 3 inside of the box. So now we have a box that has a name of lives, and it has an integer which is 3 inside of it. And this is exactly how variable works. So this is how we introduce variables inside of our code. We have the public, which is the accessibility. We have public and private variables. Public variables can be used anywhere in our code. Private variables are only used inside of the script or the class, which are the same, that we've created. Then we have the integer, and this is the type of variable that we have. So for example, right here, the integer, the variable is 3. That means it's an integer. Then we have the name of our variable, and finally we have the data that we want to put in our variable. So let's talk about the different types of variables that we have. we've talked about the integer. Now we talk about the float. So for example, you can have the velocity of a car. It's not, for example, 10 miles per hour or 20 miles per hour. It can be sometimes 4.8 miles per hour or 6.7 miles per hour. So it's always, whenever we have a variable that can have a float, we use this float velocity equals 4.8 f. And whenever we create a float, we need to add the f at the end of it. Another thing that we need to keep in mind whenever we are naming our variables is that the first word of a variable is always with a minimized or a lowercase first character. So for example, velocity, v is always in the lowercase. We'll show how sometimes we use the uppercase. So this is an example of the uppercase, and it's a variable that is a boolean, and a boolean can either be true or it can be false. This is very helpful. We will be using this boolean variable a lot in our project, so keep this in mind. And as you can see right here, the naming convention, the first word, which is in the lowercase, while the second word, which is that, is in the uppercase. So this boolean, which is named is that, is equals to true, and it can be sometimes equal to false. And the last type of variable that we are going to talk about is the string variable. And string means it's a string of characters next to each other. So here we have a box with the name of my name, and my name is Michael. So the string of characters, which are M, I, C, H, etc., etc., are stringed together to create one variable which is of string type. So let's now try and implement variables in a good way in our code so we can see the effectiveness of variables. Let's go back into our Visual Studio. Okay, so how are we going to use variables right here? Let's first of all remove the warning and error, as we'll not be using them right now. And let's go ahead and create a variable up here. But what should this variable be? Before we do that, let us create a circumstance to use our variable. So let's say here we have the press the left arrow key to go left. Let's say, for example, we need to press the arrow key several times. So press the left arrow key 5 times to go left. Very nice. So now if we save it and we go back in Unity, we click on play, we should get here, so it's press the left arrow key 5 times to go left. Okay, so let's say we want to change this. Let's say we need to press it 7 times. We save that, we go back in Unity, and we see that we need to press it 7 times. But this is very easy and conventional because we have 20 lines of code. What would you do if we had, let's say, 2000 lines of code, and you need to find this right here, this message debug.log, and you need to find the precise place where there is a 7 and you need to change it? Well, this is where variables comes in. So let's go ahead and create a variable. Let's say it's a private, so we can write private, we can write even private, and then hit the tab. So it's private, it's an integer, and it's going to be called number of times. So as you can see, I've named it this conventional way of naming variables. The first word is in a lowercase, the second word has the first letter in the uppercase, and the last word also. So every subsequent word has the first letter in the uppercase. Anyways, now we can actually go ahead and put a 7 inside of our number of times. And let's use it right here in our debug.log. So instead of the 7, we're going to add these two quotas right here. I'm not sure if they are called quotas. I'll call them quotas. We add a plus, and we write here number of times. And we add another plus. So let's save that. And let's change this to, for example, 236. We'll save that. So we go back into Unity. And now we have this 5 right here. We click on play. And now we need to press the left arrow key 236 times to go left. Very nice. And I did something in the previous video that I've noticed was too fast, and I actually can clear this console. If we click clear on this right here, we click clear, everything is cleared from our console. And another very cool feature is that you can clear on play. So whenever you hit play again, everything in the console is cleared. Okay, nice. So this was a side note. Cool. So now you can see the effectiveness of variables inside of our code. Let's go ahead and create another variable. We'll make this one public, and it's going to be a float variable. And what should our float variable be? Well, it should be, for example, the speed of, and it's going to be, let's say, 6.93. And let's see where we can add it. So press the left arrow key number of times, and as you can see right here, your instructor has just made a mistake and we did not add the f at the end of our variable. So let's go ahead and do that. One thing to keep in mind is that making mistakes is perfectly fine as long as you take responsibility for them and make sure you try to never make them again. Anyways, let's continue on. So press the left arrow key number of times to go left at the speed of, let's say, this is purely for example, and we'll add the speed of variable at the end right here and remove the quota at the end. Let's save that. Let's go back into Unity and see if that works. Click on play and press the left arrow key, and we'll add the speed of variable at the end right here and remove the quota at the end. Let's save that. Let's go back into Unity and see if that works. Click on play and press the left arrow key 236 times to go left at the speed of 6.93. Very nice. So right now we can also change this immediately to whatever we want, and it directly changes it without us going in and changing string inside of the debug.log. And this is, the variables are extremely important, and they are actually the most important part, I believe, in coding. They are used everywhere in every conceivable code that you can imagine. And that said, it's time for your challenge. And your challenge is going to be to create your own variables. So first of all, you'll need to create a variable of type string and use it in the debug.log message. You can even create another debug.log message if you want. And you need to change the string variable and check to see if it changes in the console. So pause the video right now and go do the challenge. Okay, welcome back. How did you get on? Let's talk about the 4.8 false. A string of character everywhere in every conceivable code that you can imagine. And that said, it's time for your challenge. And your challenge is going to be to create your own variables. So first of all, you'll need to create a variable of type string and use it in the debug.log message. You can even create another debug.log message if you want. And you need to change the string variable and check to see if it changes in the console. So pause the video right now and go do the challenge. Okay, welcome back. How did you get on with that? I hope you didn't just stare at the screen for a couple of seconds waiting for me. Anyways, let's go ahead and create a variable. It's going to be a string. So if we don't add anything behind the string, the variable will be public. And we're going to call this string the arrow to press, and it's going to be the left arrow, or simply left, or let's change it actually to right, and let's save that. And now right here, so we're going to press the add to quotas, add a plus, and it's going to be the arrow to press. Okay, nice. So let's see if that works, and always remember to save. The way you know if you haven't saved yet, you need to check up here, and you can see that it has a little star next to it. This means that the script hasn't been saved. In order to save, simply hold or press Ctrl S, and everything should be saved on your script. Go back into Unity, and let's click on play and see what happens. So we need to press the right arrow. Okay, nice. So let's change that into the up arrow, save that again, go back into Unity, and of course we have the clear on play. If we if you haven't saved yet, you need to check up. If you haven't saved yet, you need to check up here, and you can see that it has a little star next to it. This means that the script hasn't been saved. In order to save, simply hold or press Ctrl S, and everything should be saved on your script. Go back into Unity, and let's click on play and see what happens. So we need to press the right arrow. Okay, nice. So let's change that into the up arrow, save that again, go back into Unity, and of course we have the clear on play. If we remove the clear on play, so maybe this is a better option, so we remove click on play, and we have the press up arrow key 236 times at the speed of 6.93. Very nice. And I don't know if you've noticed, maybe some of you that are sharp-eyed noticed that in the script we have this right here in the inspector. So what is this value? Well, we can actually change this value. For example, click on play, and the value in here will also change, which is a very helpful tool in Unity that we're going to talk about later on in our project. So I hope you enjoyed the video, and I'll see you in the next one. Welcome back, my fellow game developers. In this video, we've added a platform, we've added a cube with a rigid body and box colliders that we're going to talk about. And when we click on play, our cube actually falls down and bounces on our platform. So this is a very fun video. It's one of the most exciting ones. Let's not waste any more time and let's get started. Okay, so first step is to create a cube. So let's go ahead and create a cube. Let's right click in our hierarchy right here, go to 3D object and create a cube. So now we have a cube. And as I've taught you before, let's go ahead and reset its position. And if it was too fast for you, this is the transform. These are the three buttons that we need to click. And here we have an option to reset the transform. So now it is on the position 0, 0, rotation all 0, and the scale is 1, 1, 1. Let's move it up a bit right here so we can see it clearly. And if we click on the game view, we can see that we have a cube in our game view. Let's change this from free aspect to 16 by 9, and this simply helps us to maintain a good ratio. So let's go ahead, let's go back in scene. And as you can see right here, we have a lot of things attached to our cube in the inspector. So let's talk about them a little bit. First of all, we have the mesh, and this mesh is what determines the, cube. This mesh is what determines the shape that we have. So for example, we can choose a capsule, a cylinder, a sphere, a quad, a plane, everything, whatever you want, but for now we'll keep it as a cube. Next thing, we have the mesh renderer, and this is actually where we can tweak how our cube looks. So we can change this from the default material to a different default sprite frame. Not sure what that is. That's making it a black hole. And if this sun and camera are bothering you, you can actually turn off the gizmos, or you can simply make the gizmos a lot smaller so they don't bother us. It's up here on the gizmos. Okay, cool. So now we have our black dark cube. Let's change it back to its default material. What was it? Well, default material, it doesn't matter. And you also have the lighting, probes, and additional settings that you can go in depth. And finally, we have this box collider around our cube. Now, what is this box collider? But before we talk about box collider, trust me, we'll talk about box collider. Let's first talk about the rigid bodies. Now, what are rigid bodies? Now, if we click on play, we can see that we simply have a cube and a small message that we should remove. Anyways, we have a cube right here, but nothing happens to it. It's simply a game object and it doesn't have any life in it. So how do we add life to our cube? We need to add something called a rigid body. Now, what is this rigid body and how do we add it? It's simply right here in the add component. If we click on it, we can go ahead and search for rigid body, and we have two types of rigid body. We have rigid body 2D and we have the rigid body without anything, which is for the 3D, and we are working in 3D. So let's go ahead and add a rigid body. So now if we click on play, we can see that our cube starts falling down. Why is that? Well, let me explain with a couple of slides. So what is a rigid body? It gives us control of an object's position through physics simulation. Rigid body object will be pulled downward by gravity without adding any code, and we can also apply our own forces on them. So back in Unity, this is a very simple explanation of rigid body. I've left you the documentation in Unity, or you can simply go ahead and in Google search for Unity or rigid body Unity, and you will get a link to the documentation. You can read all about rigid body. But as you can see right now, our rigid body adds mass, it adds drag, it adds angular drag, and it adds gravity. We can also make it kinematic. There are many things that we can change about our game object when we have a rigid body attached to it. And it actually makes everything in our game much more natural, and it actually adds a physical element. It makes our game work with the physics of Unity's engine, and now our cube, when we click on play, simply falls down. Now, Another option that we have is we can simply turn off the use gravity, and now if we click on play, our object doesn't fall down. So cool, that's very nice. We'll clear on play, clear that, save all of that. And what should we be doing next? Well, we should be explaining a bit about box colliders. So let's click on this right here, which is the edit bounding volume. If we click on it, we can see that there is a green square on each side of our cube, and this makes it a green cube. So we can actually change this volume. If we click on it, we can see that there is a green square on each side of our cube, and this makes it a green cube. So we can actually change this, so we can increase its size, and this is actually what allows us to interact with other game objects that have box colliders on them. So let me talk about box colliders in a bit. So what is a box collider or a collider? In our case, it's a box collider because it's around a box. So it makes it possible for objects to interact and collide, hence the collider, with one another. And we'll use it to catch objects that have a rigid body and are falling because of gravity or any other reason for them to fall. So let's go back and see what our box collider actually does. But before we do that, well, actually you are going to find out how a box collider works, because catching our cube falling is part of your challenge, and your challenge is to catch the falling cube. So find a way to stop our cube from falling into the abyss. By abyss, I mean the whatever down in Unity is. It's the abyss. I call it the abyss. And I'll give you a couple of hints, because this is a bit of a tough challenge. First of all, you need to create another cube and size it to platform size. So you'll need to create a platform under our cube. You'll need to uncheck using gravity or remove the component. And you'll need to add a collider or make sure that your platform has a collider on it. So pause the video right now and go do the challenge. Welcome back, everyone. So I hope or make sure that your platform has a collider on it. So pause the video right now and go do the challenge. Welcome back everyone. So I hope you did the challenge and it wasn't too hard. We are simply going to duplicate our cube and we'll name this the platform, and we'll move it down just a little bit, put it on the 0 position. And in order to make it bigger, we can actually play around with the scale. So let's increase the X scale and make it 25. We'll increase the Y scale. Should we increase the Y scale? Nope, we don't need to increase the Y scale. And let's go ahead and increase the Z scale. So now we have a platform. But if we look in our game, it kind of looks good. Our cube falls, but what happens? And actually nothing happens. Why is that? Well, because gravity is turned off on the cube and the platform. So let's go ahead and turn gravity back on the cube, click on play, and what happens? Well, as you can see, they are both falling into the abyss of Unity. Why is that? Well, because our platform, even though it's not being used by gravity, other forces are also affecting our rigid body. Now, there are two ways to go about it. There is the kinematic, but this leads to weird behavior because let's go ahead and make the platform kinematic. We click on play. Our cube falls, nothing happens, but if we add more cubes, the platform starts rotating. So the best way is to simply remove the rigid body component from our platform. And another thing that I wanted to talk about, so let's put the Z of our cube back to 0. The game view is good, it looks good, but it's not as good as we want. So we want to change the position of our camera. And if you click on camera, you can see how the game view right here on this little box looks like. So we want to change it. We want the position to be, for example, up here. And we can start moving our camera up and down and making sure that it works. But there is another fancier way of doing this. If we choose the way we want to look at our game scene, for example, I want this one, and we click on camera, we can actually go up here into the game object, and down we can see that we have the option to move to view or align with view. So let's click on align with view, and you can see down here that actually our view is now, well, the view that we have in our scene that we chose is actually the view in our main game. So this is a very helpful way to change the position of our camera very fast. You can also use it to change other position. You can also use it on other game objects, but I found that camera is the coolest one to do this with. So let's go back to camera. Now if we click on play, this will be our view in the game. It's not very nice. Let's change it. For example, put it up here and maybe move the box up a bit. Actually, let's change the mesh right here and make it white, just so we can differentiate between our cube and the platform it's falling on. So now our cube falls down and it falls on the platform. Very nice. So one more thing that I want to add just for fun, let's go ahead into our project. Let's right click and we can actually create. Now if we click on play, this will be our view in the game. It's not very nice. Let's change it. For example, put it up here and maybe move the box up a bit. Actually, let's change the mesh right here and make it white, just so we can differentiate between our cube and the platform it's falling on. So now our cube falls down and it falls on the platform. Very nice. So one more thing that I wanted to add just for fun, let's go ahead into our project. Let's right click and we can actually create. What should we create? Well, we can actually create a material, and this material, we'll call this the cube material, and we can actually add this cube material to our cube up here. And we have the option, we have a lot of options, you can go and check all of them, but the most important one that we need is the color. So we can change the color of our cube and make it maybe a bit red, orangey red, or keep it red. And we can also create another material. So go ahead and create a material, and let me show you again. So we hit on the right click, go to create. We have a lot of options, and one of them is the material right here. So we created a material, platform material, and we'll add it to the platform, and let's change the color to green. So now we have a green platform, or actually I think we are going to keep our platform a bit whitish, gray whitish. which is better because we are going to be adding other components, other cubes and spheres and cylinders. Each will have their own color. We'll keep this standard. Anyways, another thing, the fun part of this video is going to be adding a physics material. So down here we have the physics material or physics material 2D. We choose the physics material, and this will be the platform. Anyways, another thing, the fun part of this video is going to be adding a physics material. So down here we have the physics material or physics material 2D. We choose the physics material, and this will be the platform physics. Now this is not the most important part, but we'll need it. I'll show you why. We can change right here the dynamic friction, we can change the static friction, but what we're most interested in is the bounciness. So let's make the bounciness 1 and let's drag it on our platform. So if we click on platform and look under the box collider, we can see that our material is now the platform physics that we've created. And now when we click on play and our box falls, it actually starts bouncing. Very cool. So I hope you enjoyed this video. And I'll see you in the next one. Welcome. Challenge. Welcome back everyone. So I hope you did the challenge and it wasn't too hard. We are simply going to duplicate our cube and we'll name this the platform, and we'll move it down just a little bit, put it on the 0 position. And in order to make it bigger, we can actually play around with the scale. So let's increase the X scale and make it 25. We'll increase the Y scale. Should we increase the Y scale? Enjoyed this video and this white-ish, gray white-ish, which is better because we are going to be adding other components, other cubes and spheres and cylinders. Each will have their own color. We'll keep this is thing we have real. I'll show static 1 and let's drag slider. We can play. So video, and I'll see you in the next one. Welcome.
Alright guys, so I wanted to put together a video of this blood vine farm that I've been doing